Hello everyone. In this video, I am going to explain Kirchhoff's voltage law. According to the statement of Kirchhoff's voltage law, in any closed loop network, so as you could see here, this circuit is a closed loop network. So this is a closed loop, so where a current is flowing. So in any closed loop network, the total voltage around the loop, so around the loop we have a voltage. So the total voltage around the loop is equal to the sum of all voltage drops within the same loop. So now let us realize it through a simulation. So now for the sake of simulation, I have used a voltage source, and here we have three resistances. So to construct a loop, I have used three resistances. Let me say that the voltage drop across this resistor is V1. Here the voltage drop, let it be V2, and the voltage drop across this resistor, let it be V3. So we have three voltage drops, and here we have one voltage source whose voltage is Vs. So now let us go for the simulation. In order to know the value of voltage, let me add the test point because it is not explicitly seen. So I use a test point. So here. So here I have a voltage of 40 volt. Now I am also supposed to know the value of voltages across the resistors, right? In order to calculate the drop. So I go to output and label, and then I add a voltmeter. So voltmeter is a device, measuring device that is used to measure the voltage. So I put a voltmeter. So I put the voltmeter across every resistor. So now let me make a connection. So I add a wire, and see, this has to be connected to the end of the resistor. So I just connected to the end. And now I connected across 200 ohm, and this voltmeter is connected across 300 ohm. So we have 40 volt in the supply, and the drops across the resistances are 6.67 volt, 13.33 volt, and 20 volt. So let me add all the voltage drops because it is said sum of all voltage drops, right? So let me add all the voltage drops which are available. Before that, let me tabulate the values. So Vs, V1, V2, V3 are the three voltages. So Vs is 40, Vs is 40, and then we have V1 to be 6.67, 13.33, and here it is 20. V3 is 20. So let us add these three values. So when we are adding all these three values together, it is 40. That is, it is equal to the supply voltage. Let me now just vary the value of voltage and check if it holds good for the other values of voltages also. So now I'm making it 50. So when you have 50, the drops are 8.33, 16.67, and 25. And on calculating, it is seen that it is again 50. So which is equal to the supply voltage. So Kirchhoff's voltage law, which states that in any closed loop network, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop. So in general, Having this circuit, if we write the generalized equation, it is written as Vs is equal to V1 plus V2 plus V3. So this is when you have three resistances connected in series. What do we do when you have n number of resistances connected in series? Then you will have n number of voltage drops. So Vs is equal to V1 plus V2 plus V3, so on till Vn. So this equation is explaining KVL, which is Kirchhoff's voltage law. And if you bring all the voltages to the other side, so the equation is Vs minus V1 minus V2 minus so on till Vn is equal to 0. And in other words, KVL could also be stated as the algebraic sum of voltages within the loop is 0. So this Vs minus V1 minus so on, this is written as the algebraic sum of voltages. So the algebraic sum of voltages is equal to 0. So which is written mathematically as summation of voltages in a closed loop is equal to 0. So this is the other form of mathematically expressing KVL. Thank you all.